All right, so this presentation is going to be a little bit different than the one I did in March. So if you didn't see that one, I'll try to tie into it. Because today I want to actually show you some things that are working. I think that's more interesting than just talking about slides. I think OPI needs more terminals and more code. So I hope I can bring that. All right. So starting with the why, right? We're creating this foundation for the unknown, right? Because everything that we've been doing has been, let's say, difficult because nobody knows how to use DPUs. When you go to customers, the first thing they say is, oh, it looks good. And then we ask, how would you use this? And they say, we don't know. So we're trying to figure out how can we build this foundational platform that can be used for anything, right? So because we don't know that killer app, we just want to have this infrastructure ready so that if the customer sees how it all fits together, they can start bringing their own workloads and we can start seeing how the next step would look like, right? So the bottleneck is it's hard to manage these things. So as many of you know, you bring in this new DPU, or you're a vendor, you bring in this DPU, and it's hard to manage. You need to ramp up on all the vendor-specific details. You need to read a lot of documentation, and every card is different. This has been the huge pain point, right? So the solution in OPI is, yeah, let's build this vendor-agnostic environment, open, and any workload can run on it. That's the goal, right? So we're focusing on offloading first, and then acceleration. That's by design because we've seen this in the past. If you mingle those two goals and you try to do offload and acceleration at the same time, you will not get very far because it's just too much. So again, building that offload first as a foundation and then focusing on acceleration next. And then once we have all this set up, we can then bring in the developers and say, okay, these are the APIs. If you're using these APIs, you'll be able to leverage all these other DPUs, right? Same from a vendor's perspective. If you're a vendor, you're coming in, implement these APIs, and you should be good. You join the ecosystem, and as a, you join the ecosystem, and then as you're building new applications, you can also just use what's already there without having to reinvent the wheel. Okay. So recap of where we are. So phase one, it's really complete from my perspective, right? So we've successfully defined what is the minimal set of APIs to get anything working. We've been here for quite a bit of time and we're past that phase. We're now in phase two, real customer adoption. So we're running the first trials at customers, no longer real proof of concept, but actually developing real world use cases. And the goal is to then have actual tangible value, not just the promise or a potential. So I think demos speak louder than words. So let's just jump right through it or in it. So a lot of things can go wrong here. And I think that's part of the excitement. All right. So I am VPN'd into our own lab. The intent was to deploy what you're going to see here in the OPI lab, although there were some difficulties with hardware that prevented us from doing it. What's important to realize is there's nothing technically gating us from moving what you see here into the OPI lab. I'll talk about that later as well. So let me first go into the directory. And I'd like to also bring a diagram into the picture. So the first thing I'm going to do is make sure that I start with a clean environment because this is actually a live environment. So I don't want to break the demo because something else has been running. And what we see here is a cluster, right? So in the end, we have the OPI APIs behind the scenes. And what you then build on top is an implementation in OpenShift or Kubernetes. Like OpenShift is the Red Hat version of Kubernetes. So at the top, you can see a bunch of nodes, and on the bottom, you can see DPUs. So let me zoom in. So at the top, you can see 3 master nodes, just like any other normal cluster, 3 master nodes. That's what you see here. And then you have 3 worker nodes. And inside each of these worker nodes, you can see a DPU, right? So if I go back to the diagram, 3 worker nodes, that's what I'm showing here, x86 servers, and then 3 DPUs, okay? And everything is working in one environment. What's important here is that we're talking about an IPU, an Intel card, a Marvell card, Octium 10, and Phantom Lake. So 3 vendors all in one environment, seamlessly integrated, right? So within this whole infrastructure, there's a lot of other stuff going on. So it's useful to have the user, to give the user the ability to see what the state is. And so you have a command called OC-get DPUs. So this is, if you're familiar with Kubernetes, it gets you custom resources, gets you information, and you can see all the DPUs that it's detecting. So you see 6. Why do you see 6? Well, what this is telling you is that on each server where there's a DPU, there's 2 sides. So there's the card, and then there's the host side, and we're running a piece of software on each side, and they're looking at the hardware. And so each one of these, you see it twice, because on one side is the DPU and one side is the host. So it's as simple as that. And we give them names, a unique identifier. We can figure out how we want to display this, but just for the sake of the demo, it's a unique identifier. And then you can see what kind of DPU you're talking about, and the state being true. So depending on the DPU, it might be in a healthy state or not so healthy state. So that's what you see here. So in more detail, let's continue. So behind the scenes, there's a bunch of components running to get this working. And if you go into the namespace, I hope this is big enough. If you go into the namespace that contains all these components, you see that you have a bunch of DPU daemons. That's a component running, again, on the host and on the DPU. So that's what you see here. And on each of the different sides, right? So these things are making it so that everything is managed seamlessly for you. And all these components are using the APIs, the OPI APIs, right? And then we have a controller, a network resource injector. Those are all details, not so important, although these are important. So the VSPs, the vendor-specific plugins, of course, since vendors have particular ways of managing DPUs, we need to put that detail somewhere. So we put it into what we call a VSP, we hide it away, and from a user perspective, you don't even need to know about this, although the system needs to recognize that which DPU is running where, and it needs to start those components so that the hardware is managed. Okay, so next let's start a demo. This is where it will become a little bit more interesting. So we're going to first do some cleanup, and then we're going to start a pod on the Marvell card, and I will start a pod on the Phantom Lake. So what's important here is that from a user perspective, you're literally using standard Kubernetes primitives, right? You're applying a YAML file and not yet another YAML file, and then what you see is you get 2 pods. So if I run this again, as I was talking, it had enough time to make sure that those come up. So in this environment, now you see 2 pods in the default namespace. One is running on the Marvell card, one is running on the PTL, on the Phantom Lake. That's what you see here. Each one has an IP address. So you see, that was as easy as it gets from a user perspective. Behind the scenes, a bunch of OPI-related things happening. So now we can create more pods. And, or is this the same? Yeah, it's the same. So what I'm going to do next is I'm going to create the deployments. So on the host side, going back to my diagram here, I showed you that you were able to create these 2 pods here, right? I'm now going to create a deployment on the host side, and it's going to create some pods on x86 and some of them on this other x86 node, all plumbed into the data plane. So if I create this, going back here, so we get 5 pods. And every time I run this demo, it's a little bit different because the Kubernetes scheduler will figure out where it makes sense to run these. We have constraints like we need the DPU devices and we need like particular labels, but otherwise the scheduler is free to run it where it wants. And we see it that it ran it 3 times on the Phantom Lake and 2 times on the Marvell card. So if I get this again, so now all of these are running, and that means that it's plumbed into the data plane. going through either the Marvell card or the Intel card. And the only difference here, and that's what I want to point out, is literally, of course, a different name, but only this is the real difference here. We're just selecting a different device. It's really emphasizing the fact that these are industry standard commands. Everything is green. Let's just double check that everything is working correctly. Yeah, so we did that. And then we'll look into the IP addresses. So inside of the pods that are running on either card, we'll look at the IP addresses. So that's what you can see here. These are shown here. And then we're going to show that ping actually works. So because everything is now integrated into this like unifies environment, all these pods can talk. And that's important, right? So this pod can talk to this pod can talk to this pod can talk to this other pod, every pod can talk to each other, right? And this is really the power of when you have OPI, right? Because if you would have a vendor-specific solution for a particular card, that card would probably be able to talk to the same card from the vendor, but not to a different card, right? And because we've unified everything, everything can talk to each other. Okay, and then I'm going to show that, yeah, there's more ping examples here. So this is going from the host to the card as well. So that works as well. So you can look into the details, but the gist is really that everything can talk to each other. So if I now, instead of using a simple workload, let me just clean this up. I'll start using Nginx instead. So since you have this diagram here, the blue pods here, those are just normal pods. That's important. So we can switch out the pods for something like Nginx, right? And so I'm going to show that now. So this case is going to deploy it on the Marvell card. You see it's also pretty fast. So skip all of this. I think what I can do here is deploy this one straight. So we're going to deploy the Nginx pod. Takes a while because it's configuring the IP addresses as well. I might have skipped too many steps. Oh, it's ready. So Nginx is now ready. That's good. And if we actually check the deployment, you can see Nginx is ready. And then in this case, let's check where it's running because we did use selectors to force it to run on a particular DPU. In this case, it's running on the Marvell card, right? And then we can, yeah, so that was good. Then we can run a demo to do some kind of workload. And I think the next presentation will talk about that more. Although, because we're doing demos, sometimes things go wrong. So imagine that this worked, because it did earlier today. So that's all good. So clean up, and we're going to move that to the Phantom Lake. And again, the only difference is literally the node selector. So we select it to run on the Phantom Lake instead. So it's now coming up on that Phantom Lake card. So now we ran it here first, and we moved it here. Hopefully. So let me just run the cleanup first. Hopefully I can get this working. And then run it from here. Yeah. And again, let's have a look. Those are the nodes. And let's look at this one in particular. So you can see now the Nginx pod is running on the Phantom Lake. And hopefully we can do this part where we do some kind of prediction. So this is actually going through that Nginx pod and to the host on that side. Okay, so that this worked pretty nicely. I have a stretch part of the demo. Hopefully we get to that at the end, and maybe we break the cluster, and that's good information to have as well. So let me go back to the slides. So this is what I've demonstrated now. One cluster, multiple DPUs in the same cluster, working all seamlessly, minus that bug. So how did we really do that? Well, there's a bunch of APIs. We have a discovery API. That one is doing like the discovery of the DPUs, identifying each of the DPUs, figuring out like, okay, what kind of capabilities do we have in the cluster? We have a health probe API. So if the DPU would go down, we get some information about that because, of course, things can move, and from manageability perspective, we need to know. We have a provisioning API. I didn't demonstrate that here. That has been part of OPI for quite some while, but all those things have been deployed here with those APIs, right? And then mainly the networking API. So because we have this unified data plane now that builds an overlay across all these DPUs, everything can be managed in the same way. And this is really the power of that common standard, right? OPI. Complexity abstracted, operations simplified, because we're using standard Kubernetes primitives. So where do we go from here? If you look at the GitHub repo today, not much has been happening in OPI, if you ask me. However, what we want to do here is we want to take these APIs and we want to upstream them. So these APIs have been partially living outside of the OPI repo. We want to move them into the official OPI repo. Next one is getting hands-on experience. So today, what we've shown you is actually a pretty powerful MVP, and we really need those customers. So the intent is to move that environment into the OPI lab and get it into the hands of the customers and get feedback by asking them through surveys. Are we building the right thing? Can you start using this today? And if not, what is really missing still? However, since we've already seen that this is being used by some of the customers that we have been interacting with, we have a pretty strong opinion about what we've built, although some customers might want something else. So we definitely want to hear from as much customers as possible. And the next one is enabling more use cases. So the next use cases that we're looking at is Kubernetes FRR and Big IP, and aiming to implement both by adding a single API extension into what we've built. If you really think through this, both could be enabled by using multiple bridges, and this is also what we believe should be implemented next. And especially since some customers are explicitly asking for Kubernetes FRR, this is definitely one of the things on our roadmap. And then we want to extend the lifecycle management. So there are still some edge cases where if you reboot the system or you you kill some of the pods in the middle of the process, the system gets into this weird state. So we want to make sure that we can recover from all kinds of edge cases. The main focus will be, of course, on the Kubernetes FRR and the Big IP use case. And now this is really where I need everybody's help, right? So if you're a DPU vendor and you've not seen your DPU in that list, I really encourage you to implement those APIs. If you do, that means that we can take your DPU, add it into the same cluster, and build this bigger environment so that the customers that are coming can access this single point where they can see all the DPUs managed in the same way. If you're a customer, then this MVP is really for you, right? We really need your feedback because we need to break this cycle of we don't know where we're going. Is this what we need to build? The MVP is ready. Let's talk about what you want now. So if you're a network function vendor, right, like an actual application provider, then collaborate with us because maybe your specific network function wants to be wants the environment to interact in a certain way. and we want you to help us add it as a blueprint. So we want you to help us identify gaps and close those, and maybe extend the APIs so that we can get your network function into the same picture. And maybe you're just a general contributor, so help us define those next APIs. As of today, we've been collaborating with many partners, and we'd like to collaborate with more. So please help us, help with writing documentation and spread the word. And that's it. Thank you. Any questions? So that's a very good point. We support both. So for the sake of the demo, because it's a more powerful message if you can see everything in one page, we have the exact same setup with multiple control planes. So this is completely orthogonal to OPI, and that's a very important point. The APIs are almost below OpenShift or Kubernetes. They need to be written in a way that it doesn't force you to use one or force you to use multiple control planes. However, at the higher level, you need to use those APIs to implement whichever you want, and we support both. Anyone else? Yeah. Yeah. So I think the question is how we deal with security boundaries. Is that right? So from an OPI perspective, that's one part of it, and then there's Kubernetes as well. So from an OPI perspective, there's a single point that the components interact. So if you go back to my presentation from March this year, I think there's some of it is being answered there. But if you look here, there's a daemon running on this side and a daemon running on this other side, and both are connected through a gRPC. And everything goes through that single point. When we run in what we think is no trust mode, it's up to the DPU to listen or to ignore requests. Everything that the host side asks from a configuration perspective of the DPU is only a request. If you're in no trust mode, you just ignore the request. And if you're in trust mode, you can execute on those. And it's really at that point that you add all the security. All right. And the switches actually, or like that's a good question. I would need to think about that more. I don't think there is, but I need to think about it more. If there is a relationship between these and the Sonic and the Psi implementation. And there was one more question, I think. So SCTP would be before all of this, right? Like this is already, I've spared the pain of having to wait for the deployment because of course installing servers takes quite a bit of time. And so SZTP, is coming before, right? What we're using here is we're using Redfish and PixieBoot, although OPI has the zero-touch provisioning APIs, and they definitely have a place, and we need those. But those are come before the actual deployment, what you've seen.
We looked at other approaches as well, but Sonic was in that case, you would assign to that Sonic instance. And we did not ultimately go that way. That wasn't a general enough answer for variety DPUs, but it was discussed. And it was discussed extensively about 2 years ago. So this was one of the first discussions we had in the API working group. If you go back to those early decks, you'll see a lot of discussion about P4 packet forwarding, P4 packet forwarding, Sonic, and what should the networking API look like for a DPU? So that there was extensive discussion early on the people, the people on the API working group. Now the analog to SI on a DPU was also discussed, and we never really closed on that, right? I mean, the API group danced around that one a few times and never really closed on it. But you wouldn't use SI as SI unless you were going to put Sonic. But forcing DPUs to look like little embedded switches was an interesting idea that didn't pan out in the end. It was.
Yeah, so what I would like to add here is we're really opening up the DPU, right? It's like you can, then that's really the emphasis here. It is just another pod. If you want to do something specific, for example, if you want to use P4 acceleration, it should be part of that pod. We're not saying that you shouldn't do it. We're still building this environment, and we're seeing some customers are asking for that because they want to leverage some kind of specifics for the hardware. What we're built here is we've pushed out all those choices, all those decisions, so that what we built is actually usable today. Keep it as open as we can, and maybe OPI is just about this and not more. Like any piece that we decide on makes the future more defined, right? So if we define, let's say, at the OPI level that we want to do some kind of layer 3 firewall configuration, then that API becomes tied to that particular layer 3 implementation of a firewall. And this is the risk, right? Like initially, very early on in OPI, we've seen huge APIs that were defining all the possible things that a networking could do. And we felt like that is the other extreme, right? And it would tie us very much into what can be done at that point in time and not so much build this open infrastructure. And I think that ties into what you're saying as well.
Yeah, so it was, again, you could imagine doing that, but and you could imagine making it future forward looking. I mean, Psy and Sonic are certainly that, but it's an enormous amount of work. And Dash kind of took that approach for their gateway offload. So there's a parallel project called Dash, and it was trying to define functional models for essentially network gateway translations as an adjunct to Sonic. And that's so if you also want to look at another approach to how to break down APIs for these things, we pivoted to trying to get the platform and core infrastructure and what I call bring up APIs common and correct. And that's what was shown here today. And that's largely worked because that stuff really can be common and is straightforward enough that, but still provides value that you could do it with a modest effort. So there's certainly a lot of opportunity to have more complex, higher level APIs and more complex APIs for additional functions, but we would need a demonstrated desire for that to actually be done in common. So, and that's the wall we kept running into with early OPI, because we started with a grand vision to have, all singing, all dancing API across everything. What actually came out is very useful. This has been shown here, but just as a kind of a high level framing to follow on what Venkat was showing in this presentation.